Let's look at these two questions from simple harmonic motion. The first one is not a calculation. Using the oscillating simple pendulum above, the maximum kinetic energy is obtained at this place. That point Q is the center point, which some people call the control point, and that's where the velocity is maximum. This point X and P, they are the end point, which some people call extreme point, and at the end point the velocity is minimum or zero, while at the center point the velocity is maximum. And since kinetic energy, kinetic energy is half mv square, so where velocity is maximum, that's where kinetic energy will also be maximum. And the velocity is maximum at the center point, or that point Q, so that means the kinetic energy will be maximum also at the point Q, which is the control point. So that means the correct option is A. Now to the second question. This question is relating period of a motion of a simple pendulum, relating period of a simple pendulum with the length of the simple pendulum. So a simple pendulum has a period of 5.77 seconds. That means our T1 is 5.77 seconds. When the pendulum is shortened by 3 meters, that means we don't have the initial length. The initial length is unknown, so we put S meter. Now the new length is shortened by 3 meters. That means our L2 is S minus 3 meter. Because the length is shortened by 3 meters, we are going to remove 3 from the initial length. The period is 4.60 seconds. That is, when the length is shortened by 3 meters, T2 is 4.60 seconds. Calculate the new length of the pendulum. That means we have to find L2, and L2 is S minus 3. And before we can get L2, we have to find X first. So to do that, we relate, relationship between period of a simple pendulum and its length is 2 pi root L over G. So that means from here, period is directly proportional to the square root of the length. If we square both sides, T square, that's directly proportional to L. If we introduce constants, that means T square over L is equals to K, which can make us to have an expression like this: T1 square, using the knowledge of variation, over L1 is equals to T2 square over L2. So we bring in our parameter. Our T1 is 5.77. That will be 5.77 square. Our L1 is X, equals to our T2 4.66 square. Our L2 is S minus 3. So if we square 5.77 square to 2 decimal places, that's 33.29 over X is equals to, if we square 4.66 square, that will give us 4.66 square, that will give us 21.72. Sorry, not 4.66. There is this little mistake here, please. Should be 4.60. Sorry, 4.60 square, because our T2 is 4.60, so it should be 4.60 square over S minus 3. So if we square 4.60 raised to power 2, we have 21.16. That's 21.16 over S minus 3. Then we cross multiply. We have 33.29 in bracket S minus 3 equals to 21.16 S. So if we s times s, that will give us 33.29 s minus 33.29 times 3. 33.29 times 3. That gives us 99.87. 99.87 equals to 21.16 s. So if we collect like terms, this one will become 33.29 s minus 21.16 s equals to, when this one cross here, it becomes 99.87. So if we subtract 33.29 minus 21.16, since they are like times carrying s, we subtract. So we have 12.13. So this will be 12.13 s. 12.13 s equals to 99.87. If we make s the subject of the formula, that will be 99.87 over 12.13. So our s will now be, by dividing 99.87 divided by 12.13, I have 8.23 meter. So that means our L1 is 8.23 meter, but the question say we should find L2, that is, calculate the new length of the pendulum. And don't forget, L2 is s minus 3. That's 8.23 minus 3, and 8.23 minus 3, that will give us 5.23 meter. That means the correct answer is option A here.